The last section we will take a look at this week is 3-4, and that is on synthetic division. So synthetic division is a faster way to do long division, but it only works some of the time. Okay? Long division will work all of the time. Another thing in the book, you might see synthetic division referred to as Horner's algorithm. Okay, so if you see directions in the book that say divide the following using Horner's algorithm, that just means synthetic division. Okay, I always refer to it as synthetic division. All right, so when we're finding where a graph crosses the x-axis, okay, those roots that we're finding, some of them may be rational, meaning we can write the answer as a fraction, and some of them might be irrational. Like the one we had in the homework, I think it said positive or negative square root of 5/2. Okay? It wasn't a proper way to leave the answer, but it was irrational because it had a square root. And it wasn't the square root of a perfect square. So what I'm going to show you first is how can you find all the places where a graph would cross the x-axis that are rational. Okay? Numbers that you can write as fractions. To do that, we're going to learn a theorem called the rational root theorem, which I'll abbreviate RRT, rational root theorem. So the first thing is this theorem doesn't give you any direct answers. What this theorem gives you is a list of possibilities. From there, you have to check them, all right? But at least it gives you a list of possibilities, so rather than having no idea where the graph could cross the x-axis, it gives you some idea. And then we go from there. All right, so let's say we had a polynomial like that. The first term is the leading term because it has the highest exponent, and the last term is the constant. In order to find where that graph crosses the x-axis, you only have to, and if it's going to cross at a spot that's a fraction, you only have to look at two numbers in the whole polynomial. A leading coefficient and the constant at the end. Those are the only two numbers that are going to affect where this graph could cross the x-axis at a rational point. Now, the only thing that this doesn't work for is the constant can't be 0. If the constant is 0, then we run into a little bit of a problem.
What was that, all that set notation you had?
All that?
And I was wondering.
So,
It looks like you erased some of it.
yeah, I erased them. I can't get it back now.
I just-
Well, it says for all values of n, a sub n, the coefficients in front of all the letters are rational numbers. I could just write that in notes. So that says for that all coefficients are rational. So if you had a polynomial like square root of 2x squared minus 3x plus 4, that is a polynomial, yes. But the problem is the coefficient of the x squared term is irrational. The rational root theorem doesn't work with coefficients that are irrational. Okay, so all the coefficients have to be rational numbers. I just have that written in a nice little math way. And the constant can't be 0. So that summarizes what was written down. So if this is going to cross at a fraction, let's call the number where it crosses that's in the top of the fraction p, and the number that represents the denominator of where it crosses q. The p and the q come from the two things that I have circled here and here. So P has to be a number that is a factor of the constant. So P is a number that is a factor of the constant, okay, the number at the end. Q is what would be in the denominator, and the only options for the denominator are numbers that are factors of the leading coefficient. So P is a factor of the constant, and Q is a factor of the leading coefficient. So what's going to happen when we do this, we're going to get a list of fractions with all the different factors of the constant in the top and all the different factors of the leading coefficient in the bottom. Once we have that list, then we're going to try to narrow the list down. Okay? But it gives us kind of a starting point. Not every number in the list is a 0. This theorem gives you a list of possible roots. You still have to check. It's possible that you generate the entire list and none of them work. And that would mean that the graph you're trying to work with doesn't cross the x-axis at any numbers that are fractions. It crosses at irrational numbers. Okay, so it's possible that this theorem doesn't give us a result. So let's try it on this one. All I want to do in this problem is list all the possible rational roots. So I want to make a list of options. Okay, so remember, if this graph is going to cross somewhere that's a fraction, it's going to have a numerator and it's going to have a denominator. The numerator are all the factors of what? Yes, factors of the constant. So the numerator has to be a factor of 6. And the denominator has to be a factor of what? 10. Okay. So now I want to write every possible option that there is. Okay, we'll do it in a very organized way so we can keep track. Okay, so let's start with all the factors of 6. What are the factors of 6? Yeah?
Would be 1 and 6 and 2 and 3.
Yep, that's half of them. 1, 2, 3, and 6. And what else? There's other numbers that divide into 6 without remainders. Yep.
-1, -6, -0.
Yeah. So we're going to now positive or negative 1, 2, 3, 6. So there are 8 different numbers that could be in the numerator. Right, now let's do the denominator. What are the factors of 10? Yeah. Yep, positive or negative 1, 2, 5, and 10. So let's start listing all the different options for P in the top and Q in the bottom. Let's start with 1 being in the top. So if 1 is in the top, I can have 1 with any of those denominators in the bottom. 1 over 1, 1 over 2, 1 over 5, and 1 over 10. And I can have all those with negatives as well. So those are all the different places that this graph could cross the x-axis at a fraction with a 1 in the numerator. Okay, let's do it with a 2. Okay, what's the first denominator I would use?
2.
with a 2 at the top.
1.
1. The next one would be what? 2 over 2.
That
But
was 1.
we already have that one.
Oh, yeah.
Positive or negative 2 over 2, that's a repeat. Okay, so let's skip 2 over 2. What would the next one be? 2 over 5. And the next one?
2 over 10 is a repeat of 1/5.
2 over 10, that's a repeat of 1/5. So we don't need that one. Okay. What's the next number that can be in the numerator?
3 over 1.
Yep, so we could have 3 over 1. Next one?
3 over 2.
3 over 2.
3 over 5.
3 over 5.
10.
And 3 over 10. All right, and the last one. Okay, so now we're going to do the 6 in the numerator.
6 over 1.
6 over 1.
6 over 5. Because 6 over 2 is just a repeat of 3 over 1.
Yeah, 6 over 2 we already have. That's 3 over 1. So, yep, 6 over 5.
And we can't do 6 over 10 because that's a repeat of 3 over 5.
Yep, 6 over 10 is the same as 3/5. Yep. Okay.
Cool.
So, list all possible rational zeros. There's your list right there. If this graph is going to cross the x-axis at a place that is a fraction, it has to be one of those fractions. Any questions how we generated that list? So I'm not saying that it crosses at every one of those fractions. I'm just saying
Could have a possibility.
those are the possible places that it could cross if it's going to cross at a fraction.
How long you would check, like, or like whittle down the answers if it's between like millions and millions of answers to like 12?
Yeah, well, there's what, 4, 6, 7, 8, 9, 10, 11, 12, so 24. 24 different options. Now, what's the biggest and the smallest option in that list? Yep.
6 and 1/10. 6 is just.
6 is the biggest,
Oh, and negative 6.
and negative 6. That's a very small window to have to look at. That's not bad. Okay, so now if you go to your calculator and you set your window from negative 6 to 6, you'll be able to see if it's one of those fractions. Right? So it really kind of focused in on what we're looking at. Okay, let's graph that. So we've got 10 x to the 5th minus 3x squared plus x minus 6. I can do the standard window, negative 10 to 10. That's a little bit more than I need, but it's okay. Just make sure I typed everything in. Right, 10x to the 5th minus 3x squared. Yep, I guess that looks right. Okay, so let's look at that graph. And I want to start to narrow that list down a little bit. And see which ones wouldn't make any sense at all. How about 1/2? Does it look like the graph crosses at positive 1/2 or negative 1/2? Does it look like it's close to either one of those?
Closer to 1/2.
Okay, yeah, it's definitely not through negative 1/2. Does it look like it goes close to positive 1/2?
No.
Not really. Positive 1/2 would be further to the left. So I would say it doesn't look like that. Does it look like it goes through positive or negative 1/5?
No.
No. Positive or negative 1/10?
No.
No. Positive or negative 2?
No.
No. 2/5, that's 0.4.
No.
No. Positive or negative 3?
Definitely not.
No, that's way too far away. 1.5? No. 0.6?
No.
Not really. It's not. I wouldn't say it's that close to 0.6. 0.3?
No.
No. 6? No way. 6/5. That's about 1.1. Does that look like it's?
Yeah.
That's close.
It could be. I'd say it could be positive 6/5. I would not say negative 6/5. And then
One.
positive 1, I would say, yep, it could be. But I would say, no, it's definitely not negative 1. So out of that entire list, I've narrowed it down to it could be 1 or it could be 6/5 if it's going to cross at the x-axis. All right, so now let's look at the next question. What we've done here is we've narrowed down the list of possible options. So on the test, if I say list all possible rational roots, you write all the numbers in the black box. Then if I say to narrow down the list, you do what we just did. You cross the ones out that aren't even close to the graph. Okay? You leave the ones that look reasonable. Okay? So now, what I want you to do is find the root and explain why the root has to be irrational. Okay? So let's find the root. Second, calc, option 2. So pick a point to the left, pick a point to the right, and do your guess. And it crosses the x-axis at 0.9505. Okay, so show that it has one real root and that it is irrational. Okay, I've shown that it has one real root. Why does 0.9505 have to be an irrational number? Why can't I maybe write that as a fraction somehow? 0.9505.
It wouldn't work out as a fraction. You'd have to put it like 9505
It might be a
or
square root.
589 over like 10,000. Or like 100,000, because you can't really reduce that kind of fraction. It's too big. Right?
Okay, it still doesn't prove why that number is irrational. Why is that number definitely not rational?
It doesn't hurt.
We don't know that. Maybe it does. Maybe it ends after 656 decimal places. It doesn't. It does keep going on forever, but why? Why does that number have to be irrational? Yeah?
Is it because it's square root?
No, we don't have any square roots in that problem. Yeah?
It's not on the list.
It's not in the list. If it was rational, it has to be in this list. And 0.9505 is definitely not a number in that list. So if it's not in the list of rational options, then the only other choice is it has to be irrational. Yep. Okay, so let's just write down the root is 0.9505, and it keeps going. And this is not in the list of possible rational roots. So it must be irrational. Any questions on that? It has to be irrational. Because 6/5, that's 1.1 repeating. That's not 0.9505. And the only other one that looked even close was positive 1. That's not positive 1 either. It's 0.9505. All right, so that's the rational root theorem. Okay, so we're going to combine that with doing synthetic division in a minute. So first of all, synthetic division only works in the same situation that the remainder theorem works. You have to be dividing by x minus a number. Or technically, it could also be what? Yeah?
X minus a negative number.
Yeah, it could be like x plus a number, which turns into x minus a negative number. Now, I'm not saying you can't do synthetic division with something that's a higher power. There might be a way to modify it to do that, but we are not learning. Okay? So synthetic division is only going to be used with x minus a number. Let me see. Yeah. So what I'm going to do, I'll do it kind of like I did yesterday. I want to show that this number is a root. And I want to use synthetic division to do it. If I know that 3/2 is a root, I also know that 3/2 is a 0. I also know that the x-intercept is 3/2, comma 0. But I know something else. If 3/2 is a root, what would that 3/2 have come from? Think about, this was the last question in the homework yesterday. It would have come from something you can plug into that gives you 3/2. I want to know what that would be. Yep?
X minus 3/2.
Yes. So what I'm really going to do in this problem is, rather than showing 3/2 as a root, I'm going to show that this is a, what do we call that? Yep.
Factor.
A factor. I'm going to show that x minus 3/2 is a factor, which implies 3/2 is a root. How can I quickly show that something is a factor? Using kind of the concept we learned yesterday. Something is a factor, what do we know? When we, yep.
That if it's put where x is, then the factor is 0. It'll multiply to 0. Not sure if I'm explaining that correctly.
So what do we know about factors when you divide them into something? Yeah.
The remainder is 0.
The remainder is 0. So that's what I'm going to check. I'm going to quickly find the remainder using synthetic division. And if the remainder comes out to 0, then that means this is a factor, which means that is a root. So that's how I'm going to answer this question, to tie in synthetic division. There's other ways to show that this is a 0, but I'm trying to tie it in with synthetic division. Okay, so the first step is you're going to write down the number that comes after the minus sign on the outside of a box, just like that. Then you're going to write down to the right of it all the coefficients. So we have 2, the squared term is -5, the linear term is 1, and the constant is 3. If I was missing a term, just like when I do long division, I need to fill in a 0. And then we're going to draw our line, leave a little bit of space there. Okay, we're going to draw our line. And the first thing we're going to do is just bring down the first term. Just like that. Okay, so bring down the first term. Okay. The next step, you're going to multiply the number in the bottom times the fraction. And we're going to put the answer right there. So multiply the divisor, which is 3/2, times the first coefficient, that's the number you just brought down. And we're going to write the answer in the second column. What's 3/2 times 2? 3. That's what you do with that step. So 2 times 3/2, and put the answer in the other column. Now, that's where we got to be a little careful. What did we do with our columns yesterday with long division? No, we didn't multiply columns. Subtracted. You're not subtracting today. With synthetic division, you're going to add. You're going to add the number that we just wrote down and the one that's above it. What's negative 5 plus 3?
-2.
Negative 2. Okay, so today, add those columns up. And now we keep repeating that until we're done. When we're done, I'll explain what this bottom row means. It's going to be our answer. Okay. What's 3 halves times negative 2?
-3.
Negative 3. And then 1 plus negative 3?
-2.
Negative 2 again. Negative 2 times 3 halves?
-3.
Negative 3. And negative 3 plus 3?
0.
0. Okay. What do you think these numbers represent? 2, negative 2, negative 2, 0. Yeah,
The first one would be quotient, the last one would be remainder.
exactly. This is your quotient. This is your remainder. So that last row contains the coefficients of the quotient. And the last number, last row contains coefficients of quotient. I don't know what happened to my spacing here. I'll fix that. So last row contains coefficients of quotient. And the last number is remainder. That's what it should look like. Okay. So when you're writing your quotient, these are coefficients. Constant, linear, squared term. So the quotient would be 2x to the second. So I'm using the 2. Negative 2. That goes in front of the x. And that negative 2 is my constant. Remainder is 0. Right? So the nice thing about synthetic, it's a little bit faster and it takes up less space. Once you set up your initial problem, everything in terms of your work is going to fit in a box like that. All right, so now it says to show that 3 halves is a 0, and I've done it. I showed that x minus 3 halves is a factor. Okay, so 2x cubed minus 5x squared plus x plus 3. I want you to factor it now. Okay, well, I know it factors as x minus 3 halves. That's one of the factors. What's the other factor that you would FOIL that out to and get the original problem? Yeah?
2x squared minus 2x minus 2.
Minus 2x minus 2. Yeah, it's the quotient, right? If you know that something is a factor and you divide it into the original problem, the answer that you get is the other factor. So any question on showing that 3 halves was a root and then factoring the cubic that we had? Yeah.
How do you know your exponents on the quotient?
The exponents, so you start, that's always the constant, then that one is the linear, and then that one is squared. The next one would be cubed, and then the next one would be to the 4th. Yeah. You always start with the constant and then work your way up to as many exponents as you need. All right, let's try, I think I got another one. So use synthetic division to find the quotient and remainder. Okay, so when I set this one up, what number would go on the outside? Yeah. It would be 3 if we were dividing by x minus 3. Negative 3. Okay, so you always have to think of it as what comes in this box. Okay, and the box is what's after the minus sign. So to convert that so it has a minus sign, you've got to think of it like this. So negative 3 goes in the box. Okay, and then what would be my coefficients on the outside? Lucas?
3, 7, 1, 11, negative 11. 1.
Not
Oh,
3,
wait,
7,
0.
1, 0. Yeah. 3, 7, 0, 1, negative 11. Okay. So Aiden, what's my first step?
So you need to, well, you already wrote down your coefficients, to fill in the zeros,
Yep, did that.
just to bring out the first coefficient.
Yep, bring down the first coefficient. So bring down the 3. Dex, what do I do once I bring down that 3?
I'm not sure.
Okay, anyone help him out? What do we do? What's our next step after you bring down the 3? So we brought down the first coefficient. Yep.
Multiply the divisor by the first coefficient.
Multiply the divisor by the first coefficient.
Go to the board.
Negative 3 times 3 gives me
Negative 9.
negative 9. Okay, so we got that. Holly, what do I do with this column of numbers now?
You
Add them up. So negative 2. Kaylee, what do I do now?
You just multiply negative 3 by negative
Yep. And what do you get?
2. 6
And where do you put it?
under the 0.
Under the 0. Add them up. Negative 3 times 6 is negative 18. Add them up. Get negative 17. Negative 3 times negative 17 gives me 51. And what's 51 minus 11? 40. Okay, so we've done it, but now we need the quotient and the remainder. Okay, what is my quotient? Oh, James, how do I write my quotient?
3x to the third
Yep.
minus 2x squared plus 6x minus
17. Okay. And my remainder is going to be, yeah, 40. There you go. There's your quotient and remainder. Okay. Any question on that one? Okay. I want to show here, and I'm going to use synthetic division. There are other ways to do it. Show that 3 is not a 0. So think of what would that 3 have come from? If you got 3 as a root, it would have come from something, yep.
X minus 3.
It would have come from x minus 3. So rather than show 3 is not a 0, what do you think I'm going to show? Yeah?
That 3 is, or x minus 3 is not a factor.
Right, the x minus 3 is not a factor. So does that make sense? Instead of showing 3 is not a root, we're going to show x minus 3 is not a factor. Oh, just hold it up to the red light. There you go. Yeah. So to show that it's not a factor, what am I hoping that happens when I do synthetic division? Yeah.
You
don't get a remainder of 0.
Right, I want to get something that is not a remainder of 0. Okay, so let's see. 3, 2, 5, -2, -3. Make sure we didn't miss any zeros. Nope, I think we're good. Bring down the 2. 3 times 2 is 6. 5 and 6 is 11. 33 minus 2 times 3, 90. What's my remainder? Yeah, 90. So because I got a remainder of 90, that shows that x minus 3 doesn't divide in evenly. That means x minus 3 is not a factor. That means the number after the minus sign is not a root. Again, not the only way to show that it's not a root, but again, I'm trying to tie it in with synthetic divisions. Questions on that? Yeah?
You said it wasn't a root, it did divide evenly.
The factor did not divide evenly into the numerator. Yeah. All right, so how do we find rational roots? Well, first thing is we generate a list of possible options. Then we use the graphing calculator to narrow down that list. And then lastly, once we find something that's a root, we're going to divide by it synthetically. Because if you can find something that's a root, let's go back to one that we knew worked. This one was a root. When I divided by the root, I started with a cubic, and I turned the cubic into a quadratic. If you can turn something into a quadratic, then it's easy to solve. Okay, we got quadratic formula, where we can factor. But if you can't find a root to divide by, then you're going to be stuck with this cubic. And we don't have a formula for solving cubics. We have to turn cubics into quadratics. We've got to bring them down one exponent. So that means I'm going to have to give you a root that will work in every problem. And that way, when you divide by it, you'll get a quotient that's quadratic with no remainder. Right? But to figure out the number you need to divide by, you don't just want to start guessing all these numbers. We don't know what it would be. So use the rational root theorem to help you find the number, and then use the calculator to eliminate the ones that don't make sense. Okay, so we've got a cubic. So what we have to do now is get it down to a quadratic. Only way we're going to do that is if we can find a root and divide through by it. I have no idea what number to try dividing through by. So what theorem is going to help me to generate a list of possible things to try? Yeah. The rational root theorem. Yep. Okay, P are all the factors of the constant. What are all my factors of the constant in this one? Yep.
1.
1. There's more.
Oh, 2.
2.
Plus or minus.
So the factors of the constant are plus or minus 1 and 2. What are the factors of the leading coefficient? Yeah.
Just one.
Say it again.
Factors of the leading coefficient would be one and three.
No, 3 is not a factor of the leading coefficient. Yeah.
Just be 1 and 1, but you already have 1, right?
Say it again. It would be
Just be 1
and.
and 1.
No. 1 and
Negative.
negative 1. So in this case, because it's only 1 and negative 1, Q doesn't really, it doesn't really matter. Dividing by 1 or negative 1 isn't going to affect my possible roots. So what are all the different possible rational roots?
Positive and
plus or minus 1 and plus or minus 2. So let's graph it and see out of those 4 possibilities which one seems like it works. There's so few, I could probably plug them in for x one at a time and see which one comes out to 0. Like I think 2 is going to work because 2 cubed is 8. Minus 3 times 2 is 6. 8 minus 6 is 2, and 2 minus 2 is 0. So just by plugging in 2, I can already tell 2 is going to work. Is everyone okay if we just go with 2 then? All right. If I had fractions, like it might be kind of hard to tell, or I had a lot more roots than that, then I would go through the process that we did right here. Okay. That's way too many numbers for me to plug in, and there's fractions. So, and I have something to the 5th power. I can't do that in my head. But this problem was a lot easier. Okay, so plugging in 2 does give you 0. So let's divide through by 2. And we already know the remainder is going to be 0. So plug in 2, 1, 0, negative 3, negative 2. Bring down the 1, multiply, add, multiply, add, multiply, and there we go. So we just proved that 2 is a root. So let's make a list. 2. Now I've turned my cubic into a quadratic. What's the quadratic that I have now? Yeah?
1x or x squared plus 2x plus 1.
And that's a quadratic. So now you can either try solving that by factoring or using quadratic formula. Okay, I think we can factor that. Yep, x plus 1, x plus 1. And that will now allow us to get the last 2 roots. So what's the other root? Yeah?
Minus 1.
Minus 1, and that's a repeated root. You don't have to write it twice, but it means it's going to come up and touch the axis and then bounce away. Minus 1 was also in our list of possible rational roots. So had you done the synthetic division with the minus 1 first, you would have had a little bit different quadratic. But when you factored it, you would have had something with an x minus 2 in it, because that's how you would have gotten the other answer. All right, so it doesn't matter if there's more than one root you can divide by synthetically that you know works. Pick one. Doesn't matter which one you use. Yeah?
I was able to find that really hard for just doing the second cat.
Yes, but when we get into imaginary roots, which we're going to do next week, you're not going to be able to use a graphing calculator anymore. Yeah. So,
There's no like fraud or blind ball error. Just like, yeah, I don't know what this is.
yeah, the graphing
What are you
calculator
telling me to find?
can't do it.
I think on my calculator, there's like imaginary functions.
So if you understand the process that we're doing now, then when we do it with imaginaries, very easy.
Yeah.
But yes, you can double check your answer that way too.
Yeah.
Yep. The other problem with the calculator is it will not give you exact answers. So if I ask you for an exact answer, I'm going to want something like, and it's a quadratic, 3 plus or minus square root 7 over 5. The calculator will give you a decimal, but it won't give you what I just said. Okay, so this one says find all rational zeros. I think the last one said the same thing. No. Okay, so let's use the rational root theorem. What are my factors of the constant? Yeah. So minus 1. And what are my factors of the leading coefficient? Nick, what are the factors of my leading coefficient?
Plus or minus 1, plus or minus 6, plus or minus 2.
So all my possible rational roots are basically 1 over all the q's. So 1 over 1, 1 over 2, 1 over 3, and 1 over 6. Okay, so if this is going to cross the axis anywhere that's a nice rational number, it's going to be one of those fractions. Okay, it's too many fractions. I don't really want to try them all. So let's just graph it and use that to help us. 5x squared plus 3x minus 1. Okay, I'm looking between really just -1 and 1. So I probably should have zoomed in a little more. I can tell it's not a negative answer. So zoom in. What number does it look close to for a rational root?
1.
I don't think it really goes through 1. At least to me, it looks like 1's too far over.
Ooh. 1/2.
I would say 1/2, and I can check it quickly by pressing trace 0.5. Yep, that gives me a 0.
Makes sense.
Okay, so let's divide through synthetically by 1/2. Okay, my coefficients, 6, -5, 3.
-1.
Yep, I'm not missing any. 6, -5, 3. All right, and what do we know the remainder is going to be? We should already know this. Yeah?
0.
Yeah, we already know it's 0 because I checked it and I know that it's a root. So it is going to come out to 0. But we need the quotient. So I'll bring down the 6. Half of 6 is 3. -2. -1. 2. And then half of 2 is 1. Add it up, we get 0. Okay, so now I need to focus on the quotient, which is a quadratic. 6x squared minus 2x plus 2. Okay, check the discriminant on that. B squared minus 4ac. B squared minus 4 times a times c. What's going to happen there?
That doesn't go nicely. That becomes a negative, right?
That would be a negative, which means what?
It's imaginary.
Right. The answers here are imaginary. So now, if this was next week, I would have us continue and find the imaginary answers using the quadratic formula. But because b squared minus 4ac comes out less than 0, that's the part that's under the square root. The directions didn't say to find the imaginaries. It specifically said find rational zeros. So the only rational 0 is what? 1/2. Yep. There are 2 imaginaries, but we are not finding them. It's imaginary. Okay. Question on that one? Okay. That we're not doing. That we're not doing. That we're not doing. So I guess we can try to do this last one. All right, so this one says find all real zeros and let me know if they're rational or irrational. Let's start with the rational root theorem. The first problem I did today had a lot of P and Qs. I generally don't give you that many. If you've noticed, all the other problems have a lot less. That's usually how I set it up on a test. Okay. What are my factors of P? Yep.
Plus or minus 1, then plus or minus 2.
Times 2. Okay. Factors of Q. Oh, pull. Factors of Q.
Q.
All right, well, what are we looking at when we're trying to find the factors of Q? Which number? Okay, anyone help them out? Yep.
You're looking at the leading coefficient, which is 3 in this case. So
Yes.
Plus or minus 1,
Plus or minus 1, plus or minus 3. So what are my possible rational roots? Whole list of them. Yep.
1 over 1, 1 over 2, 2 over 1.
Wait, 1 over 2? I'm not sure how you got that one.
I'm sorry, 1 over 3.
Yeah.
2 over 1, 2 over 3.
Looks good to me. Let's figure out which one is going to work. Okay, I have to give you one that works, otherwise you're not going to be able to turn this into a quadratic and then you're stuck. 8x squared plus x plus 2. Okay, I'm going to leave my window zoomed in because I only need to look from -1 to 1. That's the biggest and the smallest. And which root looks reasonable in that list?
Plus or minus 2/3.
All right. Let's try the 2/3. Yes, that one works. I thought -1/3 might have worked, but if we check it, no, it's not -1/3. It looks close, but it was the 2/3. Yep. Okay, so let's divide through by 2/3. We've got 3, -8, 1, 2. Bring that down, multiply. -8 plus 2 is -6. What's 2/3 of -6?
4.
-4. Add that up. That's going to give me -3. And what's 2/3 times -3? -2. Remainder of 0. Okay, so 2/3 is a root. And that is rational. The other two roots are going to be a, b, c for my quadratic formula, -b plus or minus b squared, 4ac all over 2a. Minus a minus becomes a plus. Let's see, 4 times 3 is 12. 12 times 3 is 36. 36 and 36 is 72. I could reduce that answer, but I'm not going to. Okay, those are my other two roots, and those are irrational. So that's how you get the other two roots, quadratic formula. Okay, and that's 3, 4. So what I'll do is I'll pause the video after I put the homework up, and then I'll put the list of topics that are going to be on the test. On 183, I need to get rid of a question. Okay, 31 and 32. Remember, when it says Horner's algorithm in the homework, that means synthetic division. Okay, so those are the questions for homework. And again, I will be after school today for extra help.